Hey folks, this is Dave again with Advanced MasterCAM, and today we're going over Project 8. Project 8 is very similar to what we did in Project 7. We have a part that we actually created in SolidWorks. This is the finished part here, and in addition to that we've also created a casting of that part too. In the real world you probably won't use a model that actually resembles a casting. It's kind of handy because you know for sure that you're missing, you're definitely hitting material, not hitting material. In our particular case, wherever you see machine marks, we have an additional 125 thousandths of machining allowance. So wherever you see these tick marks, there's an additional 125, or the holes are actually missing. So let's go ahead and jump over to MasterCAM and let's get started. First thing we're going to do is we're going to open up that casting. So I'm going to come to the desktop, switch this here to make sure it says SolidWorks. You'll probably have MasterCAM on it. SolidWorks file, there it is, and open up Project 8. And here it is. I'm going to hit F9. I'm going to rotate this thing. I'm also going to move this because what I have here is, right now I'm on top WCS. When I click top, I'm actually looking at what I think is the front face. So let's go ahead and 3D translate this. So translate 3D, select this guy, and we're going to take what is currently the top view and make it the front view, and we're only going to move. So make sure you don't have copy, we just want to move. And approve that, and it'll rotate it the 90 degrees for you. So now when I click the top, we are now looking at the top of the part. It just helps with the orientation. So the next thing we're going to need to do is we're going to import our casting, and we're going to be using that to drive our stock. So let's go File, File Merge Pattern, navigate to your desktop again, select SolidWorks files, and we'll do Project 8 casting. Now it imported just fine, and it too is in the wrong location. I'm going to clean some of this up here real quick. Let's come to levels. We're going to call level 1 CAD. Don't know if we'll actually be using any CAD in this project, but I have to keep it consistent. So number 2 will say solid, and number 3 will say stock. So we'll need to move our finished model to solid and the casting to stock. So clicking this guy here, right click on level, move him to level 2. I can come and turn the visibility level 2 off. Now I can click this guy and move him to level 3. Now he is also oriented wrong, so we're going to rotate him too. So X form, translate 3D, this guy here. We want the top view to become the front view. We're only moving it. Clear the colors. So now when I turn on the second one, you barely see anything. That's fine. So next we're going to do is you need to set up our machine type. So let's go to mill, and we're going to choose a generic Haas 3X mill. Now if you don't see it here, click in Manage List, and it'll be in this left hand column here. I already happen to have it set up, so you click here and you'll get this in your toolpath manager. So let's open this up. We'll go into Files. On Tool Settings, click these first 4. For stock setup, we're going to do solid. We'll click on this arrow here. We're going to select that solid that we call our casting. We want to display it, we want to show up as a solid, and we'll prove it. Now we'll come back, activate layer 3, turn on the visibility of layer 2, turn off the visibility of layer 3, and there we go. We now have our finished part nestled nicely within our casting. Now you may see, you'll probably have this area here, and what it is just the way the fillets were created between the two models in SolidWorks. It's nothing we really have to worry about. In reality, the castings would vary from part to part anyways. So now that we got this all situated, let's go ahead and we'll get started. Now for me, I would say that the first operation I would want to start with is putting the part in the machine like this. It'd be sitting on a fixture, it'd hold it somehow. We're not really worried about fixture design right now. I'm just going to set my WCS to the center of this bore. It may not be the most appropriate one in reality, but for the purpose of education here, we're just going to go ahead and set the origin right at the center of this, right at the finished height of this machine. So let's go to WCS, Plane Manager. We're going to click Solid Face, and we're going to click this here. And we're going to navigate through our options until we, I just walked right past it, until we get the one we like, where the X is going to the right, Y is going to the back, and Z is going up. Now, it's not in the best spot, but that's okay, I can fix that. I'm going to call this bottom ups. And right here, the select new origin, I'm going to click it, and I'm going to highlight the edge of the circle until it snaps to the center. And that's what I'm looking for. So there's our bottom ups. So now what we need to do, we're still on WCS top, TC plane top. Come over to WCS, click name planes, bottom ups, planes, name planes, bottom ups. So now we got bottom ups and bottom ups. So every time we do a cutting operation, it'll use those to drive it. So let's go ahead and start a facing operation. We're going to face this thing. And ignore that warning that came up. It was just, I must have clicked on something. So this will come up. Now if you're using X9, you'll have a couple more options here. The only two I wanted, these two right here, loop, because we're actually going to use loop. I'll select that, make sure it's doing this loop, not that loop, and all that does is it just toggles between those two faces. So that's the face I want. We'll prove that. Come to tool. We'll come to tool type now. We're going to be doing a facing operation. Come to tool, and I'm going to create a new tool. I'm going to create a face mill. Go to next. Let's use a 2.5 inch face mill. Secondary diameter is 2.75. Overall length is 2. That's fine. Cutting length is 0.25. Let's do 0.375. And it doesn't. This information would make more sense if you actually had your tool with you. Chamfer angle is 45 degrees, shoulder length 2, and upper diameter, that means we have to do overall length of 3, and upper diameter of, say, 1. That looks kind of more like a shell mill. So let's go to next, and we'll look at tool number 1, feed rate. Now, in your X9 you'll have a bunch of more information than I will here. Just ask your instructor on how to use that if you need some more, need to know how to use it. But for me, we're going to do 1500 RPMs on this. Now, we have 6 teeth in this cutter, so 1500 times 6 times 0.002, 2000 chip load, leaves 18 inches a minute. Plunge rate, I kind of like to use 20, because I don't plunge a shell mill. 20 is just kind of a little faster movement. It's 6 teeth, it moves clockwise, it's carbide tipped, and I'm going to turn on the coolant. Come over here, we'll call this 2.5 inch face mill. For face mills, I kind of leave, I'll do 45 and 5 for both rough and finish. So we'll finish that up. Now the benefit of creating a tool here in your list is all this information is set for you. You don't have to change it every single time. If you pull from a library, oftentimes this information is going to be set to what the library has it, and it may not be what you want, and you're constantly finding yourself changing it. So let's go over to cut parameters. Looking at zigzag, cross overlap 45%. Long overlap 110 looks fine. Approach distance 50. Exit distance 50. Maximum step over 45%. We zero this out because we want it to cut all the way to the surface. We don't need depth of cuts, we'll turn it off. Linking parameters, we will come down to 0, that's the face we have. Top of stock is 125 thousandths above that. Feed plane is 200 thousandths above top of stock. Retract is another 250 thousandths above top of stock. So, okay, so let's go into our planes, make sure this says bottom ops, this will say top top and grayed out, that is correct, with a work offset of 0. So we'll prove that. As you see, we have a nice cross entry and an exit of 110%. So we can quickly go take a look, see what we see if we like what we've done. And there we go. We have a nice flat bottom, which is what we needed for our drawing. So we'll close that out. Come back to our part. Okay, so we're back in here, and now we're going to do, we're going to go ahead and profile this guy here. So let's mill tool path. We are going to do a contour. We are going to go ahead and leave this loop count, and we're going to select this loop, and that's the correct loop we're looking for. So the tool, we're going to use a 3 flute carbide, and we'll use a 4 flute. So let's create a new tool. In mill, we'll do a 0.75. Overall length is 4 is fine. Cutting length, we'll need a little bit more. Let's go 1.5 on the cutting length. There's no corner type. Shoulder at 1.5. Shank diameter of 0.75. That looks good. So let's go to next. Leave the tool number 2. Now feed rate. I said 80 is our surface feet per minute. I believe I had mentioned that. If not, we are machine cast iron, and then we're going to use 80 for if it were with high-speed steel. But this is carbide, so we're going to multiply it by 3. So we have an SFM of 240 times 4 divided by the diameter of the cutter. We have an RPM of 1280. Let's multiply that by the number of teeth, which we have 4 times 0.004. We'll use 4 thousandths for a 3/4 inch cutter. Feed rate of 20.48. Now in reality, what you'd be doing is you'd be contacting your tool manufacturer, looking up their catalog. Oftentimes these cutters can actually achieve a lot higher surface rate. I've seen carbide and steel doing 800, 850 SFM. But for purposes of this, we're just going to go ahead and stick to the 2 to 3 times rule of HSS. More likely the 3 times. So let's go ahead and look at the plunge rate. Once again, we're not going to be actually plunging this cutter, so let's take it at 25. Retract rate of 50. 1280 is RPM clockwise, and we have 4 tooth. It's carbide, and we're going to say this one does not like coolant, so we're going to leave it off. Just change this information over here. 0.75 flat end mill. Now for my end mills, I'll run 40 here, 15 here, and then 25 and 10. That's pretty decent numbers, and that's more for dynamic milling. So we'll finish that guy up. Cut parameters, we'll leave this at computer comp, 2D, compensation left. We will activate depth of cuts. We can actually change this a little bit. This is being driven. Let's come back into here. Open this back up. It's calculating. There it is. This rough Z, put that to 50%. We'll also do 50%. I'll leave it at 10 for now. So we'll finish that. Now when I come to depth of cuts, see it changed to 0.375. That's where that came from. We don't need any finish cuts. We don't need a finish step. We are going to keep the tool down. Next is lead in, lead out. We'll shorten this up a little bit to 50% of the tool. Pass it over here, and then we're going to have a little 20 thousandths overlap on where the tool comes in and tool stops. Multi-pass. Now I'm going to do one multi-pass. It's going to have one rough followed by one finish, and that finish pass is going to have, I'm going to say 20 thousandths on that finish pass. And we'll go ahead and use the default feed rates. We'll machine at final depth, and we'll also keep the tool down. So for linking parameters, the only thing we should have to change here is the top of stock is still okay. Actually, top of stock is now 0 because we shelled it. We'll leave the feed planes there. And depth, we're going to actually click on it right there. That was the top of this pad. And we'll give it a little bit more depth of cut. Let's go 1 point. We'll go all the way down to 1 inch. planes, we'll see leave this at bottom ops, top and top, and we'll prove it. As you can see, it kind of went around and does this nice finish pass for us. So let's take a look at what we got so far. I always like to have my colors turned on so I know what's doing what. So it comes across and then profiles our part. Now you notice it's also hitting here. That's okay. I'm not too worried about that because that isn't going to end up being machined exactly the same width as that, but we'll do that one from the top. So, looking pretty good so far. If you're worried about this one, we can always reduce it, but I'm not worried about it for the sake of this one. So next, let's go through and center drill our holes. So mill toolpath, drill. We'll pick the center of all 5 of these parts. And the order you pick them is the order they drill. See, I got that in the wrong spot. So edit. Okay, well, let's see. I'm going to reselect those. Mill toolpath, drill, and reselect these center points. I didn't wait for the arc center to take that one, so we're good now. Now tool here, I'm not going to create a new one. I'll just go ahead and select from library tool. Let's change our filters so that we only have our center drill. I'll take a number 3 center drill. Speed, feed per tooth, plunge, that's all sounds pretty good for me. I'm not going to worry too much about it. You actually probably want this thing spinning faster. And you want to make sure coolant is on when you get to it. So cut parameters, we're going to just do a drill counterboard. Linking parameters, in negative 0.05. Top of stock is at 0, and retract is 0.1. We don't need a tip comp. Planes WCS is fine, and coolant is on. So it'll come through and spot drill these for us now. Next is these holes. Looking at our print, the diameter of the hole is 0.41. Now I quickly went to the internet and pulled up a drill chart here. This may be real hard to read because it's grainy on my end. It's going to be even more grainy. The 0.413 I'm showing as a letter Z. It's 0.413. It's 3 thousandths bigger. A lot of these drills are a couple thousandths undersized anyways. So we're going to go ahead and run a Z drill on these particular holes. So let's come up, mill toolpath, we'll drill. Actually, we don't even need to do that. What we're going to do is we're going to take this toolpath here, we're going to copy it, and then paste it. Now, be careful when you copy paste because it'll copy everything that has a green check mark on it. I only had that one check marked when I hit copy, so it only produced one instance of it. We're going to come back into parameters. I'm going to change my tool. So we're going to select from library tool. We're going to filter out for drill bits this time. That's this icon, not the center drill. Yours may be your filter icons may be a little different in MasterCAM X9 or later. So I'm going to zoom through here till I get to see if I can find a letter drill. Letter F, letter Y, letter Z right here. Now, do we like the feeds and speeds? No, we don't. So this is only a high-speed drill, so we'll take 4 times 300, times 80 actually, because there's cast iron, remember, divided by 0.413, 700, and we're going to divide by 2 to slow it down, so 387 is the spindle speed. So 387, and we're going to do about 4th thou per revolution. So times 0.004. That means we have a feed rate of roughly 1.5. I'm going to do 1.6. You see it does a little over 2 thou chip load because there's two teeth. So we'll go ahead and approve that. Well, we got a couple other things we got to do. Cut parameter. We're going to do a chip break. We're not going to pull the tool back out. We're just going to break the chip as we're going down. The PEC is, we'll use 0.413 divided by 2. I like to use half the drill. Linking parameters, top of stock is 0, retracts 100 thousandths. Depth, we are actually going to the bottom of these holes. We're going to do a tip comp. So we want to bust through those holes. We want to come out 125 thousandths because remember this casting's still got the pad on it. So we're going to come out, break through 125 and add this tip on. Planes, bottom ops, coolant is on, and we're going to approve that. But we got to make some changes here. Regenerate toolpath because I don't want to drill the center hole. So let's come into geometry and find the point. So we want point, I believe this is 0.3. Yeah, see the little cursor shows up here? I'm going to just delete it. So delete that point. Oh, that didn't work, so I'm going to try it again. It's under geometry. Just highlight 0.3 and delete. There. Regenerate. And you see it only does those 4. Let's look at our simulation again and see what we get. Okay. So only spot drills left here. Next we're going to go ahead and drill this one out. Actually, maybe we'll drill, actually let's go back and add this in here because we're going to use a clearance hole for it to mill and leave about 20 thousandths to 10 thousandths on the wall, and then we'll bore it. So let's go back and make that correction. We want to add that point back in there. So let's click on geometry, click add points, and we're going to just add that one. Regenerate, and it's the order's a little weird, so let's come back in here and click sort options. Okay, so that's that sort option. Don't really care for that one, so let's sort again. Same style, but let's go this direction here. There, that's a little bit more efficient. Looks better. In fact, we'll come back to this geometry. We'll resort this one too. Okay, that looks better. So now we'll have our whole. Ooh, you know what? We can't do that because we need that hole to come all the way through this for that mill. Shoot. Okay, let's go back and delete it back out. So we'll highlight 0.5 and just hit highlight 0.5 and hit delete on your keyboard. That's all you need to do. Now we'll take this one again. We'll copy it. Where's copy? Oh, I'm losing my mind. There it is. Copy. Paste. Same thing. Except we're going to go through. We're going to change our geometry. We're going to reselect all. This time we're just selecting the center one. Approve that. Go to parameters, and we just got to change our linking parameters to the depth all the way down here. We'll approve that. Regenerate toolpath. Now let's see what we got. That hole should go all the way through. Now I don't know if you noticed that, but that drill bit bottomed out. So in reality, you have to be real careful that you don't smack your tool holder right into your part. So your bit needs to be long enough to actually get all the way through it. Okay, well, we're looking good now. Well, let's go ahead and in reality, would we be able to, we might be able to bore that all the way out in reality, but be able to drill or pocket that all the way out in reality? Probably not. So we're going to go ahead and pocket this into, just from the bottom operations, we're going to get halfway through it, and then when we flip it over to the other side, we'll go halfway through again, and then we'll bore it from the other side. Okay, so let's pull up a mill tool path. We're going to pocket, while we're in solid select, I'm going to chain that edge. It's hard to tell which surface we have. We won't know until we develop our tool. In our tools, we have not the right tool. So we can use that 3/4 inch. Let me see what our size is here. Okay, so looking at this now, maybe that hole in the middle wasn't the right size. We probably should have maybe bumped up to a 3/4. Let's go fix that real quick, because this hole here is an inch. We're going to use a 3/4 to basically clear it out. So let's close this down. Come back up to here. We're going to open up a new tool, or just select from the library. Looking for the 3/4 inch. There it is, 3/4 inch drill. Got to check our feeds and speeds. So 4 times 80 divided by 0.75 divide by 2. Sorry. Okay, let's try that again. 4 times 80 divided by 0.75 divided by 2. 213 RPMs. And we're going to do it probably 7th chip load per revolution. So time is 0.007, feed rate of still 1.5. So 1.5 here, 213 RPMs. Looks okay. Cut parameters, everything should be fine, except we want to change our depth to 0.375. We could probably do more than that with this probably 0.75. We can go the full diameter before we pack. Coolant, we still want our coolant on. We'll prove that and regenerate. So now when we go looking at this, we have an appropriate clearance hole for a 3/4 inch end mill that we'll use to pocket this thing out. So it probably would have been best if we did these holes first for sake of order, because we were putting the 3/4 inch away and then pulling it back out and use it again. So we may reorder these tool groups when we're done with this bottom operation, just to kind of make things more efficient. Let's go ahead and pocket out this hole, leaving 10 thousandths on the wall. So now we'll come up mill toolpath, pocket, and we'll select that. It's hard to tell which face is right. So tool is this 3/4 inch end mill, leaving all of our information here. We're good on that. Cut parameters are standard. We want 0 on the floor, and let's do 10 thou on the wall. Our roughing entry will have off on the entry motion, because we're going to use that clearance hole we just created. Roughing will do true spiral. We're not going to do any finishing, so I'm going to turn that off. We are going to do depth of cuts at 0.375. We're not going to worry about breakthrough, because we're not going to get all the way through this guy. So linking parameters, we're going to do depth of here. We're going to divide that by 2, because we're only going to go halfway. And I'm going to increase it just a little bit so we have a little bit of overlap. So 1.2. Top of stock is actually at 0. Feed plane there is good. Planes, bottom operation, coolant off, because this cutter likes to cut dry. But you know what? It would help to actually, we're going to turn coolant on in this case, because we need to try to get the chips out of this pocket while it's making. You don't want to double cut chips. So if we had maybe blast air, it'd be more efficient. Depends on the cutter. So as you see, it's gone down and it's created our holes. Once again, let's review. See what we get. Shell, profile, center drill, drill again, and pocket that out. Now I'm going to go through and we're going to reorder these guys to where it makes more sense, because I use this 3/4 inch cutter to cut this profile, and then I pull it back out to do this bore. So we did an unnecessary tool change. So looking at this, facing is a very good one to do. We're going to take the PEC drill, this one with the center drill, and we're going to take it, close it down, and we're going to drop it right there. So now it's second operation. Next will be the drill with, let's see, we'll do this, we can do the Z drill next, which is fine, followed by the 3/4 inch, and then a contour and pocket. That is probably much more efficient. So this is all the bottom operations. And to verify that we do have our operation in order, we can go ahead and resimulate. So center drill, profile, 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 and then pocket out without a tool change. There we go. We now basically have the bottom done. So let's go ahead and hide all these tool paths. We don't need them. Next operation is we're going to work on the top. And what we got to do on the top is we got to surface this guy, these pads here, finish trimming these to their, we're actually going to leave these alone. We're going to do them on their edge. Well, do we want to do that? No, we'll go ahead and profile them off. No big deal. That way we don't have to do two sides. If I machined it up on its edge and I profiled or machine this one and then drilled through here, I would still have to flip it over to the other side to get this pad off. But if I go ahead and do it from the top, we can profile this off in one pass and I only have to do one side operation versus two. So save some time. Okay, so let's go ahead, bust out our 3/4 inch end mill. We'll leave it in. We're going to create a new tool path group. So do you really need to do it? Nah, not really. There, that puts it down. I'm trying to reorder these guys here. Okay, so we'll call this toolpath group bottom, B-O-T-T-O-M, op. We'll call this toolpath group top op. And bring our red icon below it. So we got to create a new WCS. I'm going to once again use the center of this board for that purpose. So plane manager, solid face, select this guy. I'm going to have it kind of sitting in my machine like this, so we'll go through our options until I get this. Looks pretty good. Give it a unique work offset. Call it top op. I'm going to select the center of that circle and I'll prove that. Now in WCS's, name planes top op, planes, name planes, top op. And there you see our new orientation right there. So let's go ahead and with our 3/4 inch end mill still installed, we're going to do a face, multiple faces at one time. So let's select, other face, that face, that face. I'm going to see if this works. I haven't done this before, but I think it will. That face, that face, and it may not. I may see this as island pocketing. And that face. Okay, tool, 3/4 inch flat. All of our variables are still set since we created that tool. Cut parameter, zigzag is fine. Leaving all the parameters we have. Depth of cuts 0. Linking parameters, leave this as incremental. So leave that at 0. Top of stock is 125 thousandths now, above 0. So feed plane, these are all good. Top op, top, that's good. Coolant off. Let's see if it works. Cross your fingers. Hey, look at that. Now it does cause us a little bit of problem. The orientation is bad. So let's go ahead and open up our parameters. Cut parameters, rotate things 90 degrees. Improve that, and let's see if we get a better result. Now the question becomes, do I miss the wall here and here? My gut says I don't. Let's take a look. Bam. See, I hit that. Okay. How do we fix that? We may not be able to. We may just have to do these guys separate as one pass. I think a 3/4 rule may do it. Okay, well, it was worth a shot. So let's go to geometry here, open up these solid chains, and delete that loop, that loop, that loop, and that loop, leaving only the top loop. Regenerate. That looks good. So let's see. Let's check mark that one. We're going to copy it and paste it here. For geometry, we are going to rechain all. Other face. We're going to do that one, that one, that one, and that one. Come to parameters. I'm going to try to see if we can get away with one way. Actually, one pass. See if it'll do it. Let's prove that. Regenerate toolpath. Nope, tool diameter is not good enough. So let's come back to parameters. Let's go zigzag. Prove that. And we're still going to hit. So let's see if we can adjust the parameters to where we don't have enough overlap here. Okay, well, this facing operation just really isn't working very well. So we're going to get rid of that. I'm going to go ahead and do a pocketing. So let's make sure you only have that one green check mark and hit delete. If you have multiple check marks, it'll delete everything check marked. So mill toolpath, pocket, and we're going to go through and select these spots. Tool, 3/4 inch end mill, cut parameters, stock to leave on the walls. I'm actually going to do something a little different. I'm going to negative 0.01. So what that's going to do is going to go beyond the wall 10,000ths of an inch, making sure we eat, get a bite of everything. Maybe let's increase it to 20,000ths. So roughing, I'm going to go true spiral, entry motion. We'll go ahead and do a helix. It's really not necessary because we're going to leave it off because we have a clearance hole. We're not center cutting. Finish. Let's do. So do we want to do any finishing? No. Let's not do any finishing. Depth of cuts. No, we don't want depth of cut because we're going to be able to do this all in one shot. Linking parameters. Top of stock is actually here plus 125 thousandths. The feed plane is going to be this number here, add another 100 thousandths to it. Retract is an absolute. And we're going to come up 0.2 on that one. The depth is also absolute. We want to come down to that ring. So there's our values that we need in order to control this tool. Leave your planes at top. Now if you have this wrong, this retract wrong, when it pulls up to go over to the next pad, it'll likely run across things. So let's go ahead and take a look and see what we got. We want feed plane to be there. We want the feed plane to be absolute too. So everything's absolute. Okay, so let's take a look and see what we get. So there's a little circle at the bottom. Turn on all our machine groups, see if we're getting, make sure we're not missing anything. Okay. So I actually did something wrong. I went too deep. I actually need to be on top of these fillets. So let's go redo that. Under parameters, top of stock is going to be here plus 0.125. Feed plane is going to be, is this value here plus 0.1, and depth is going to be there. So that should be better. Let's go ahead and regenerate that toolpath. Yeah, see the circles now are right at the top of this bed. Let's highlight everything and go ahead and simulate again. We didn't. For some reason, that path did not get selected. Okay, that's much better. Next operation, we're going to just go ahead and keep going along with this 3/4 inch. We're going to go ahead and profile mill these guys off and also deal with that hole. So, how are we going to do this? Let's project this circle to a flat plane. So we're going to make sure we're on level 1. I'll turn off all these tool paths. And we're going to do X-form project. Okay, we got to duplicate this edge first. So create curve on one edge. We want that edge, and we want that edge. Change this to 2D. X-form. Where's project? Project. This line, and this line. And it brings it up to a nice flat line. Now I can use those lines as a guide for the cutting tool. It's also wise that, see, we have CAD here. I'm going to create a new level 4. I'm going to call it cutting machining tool paths. That's what I'll call it. Because anytime I use a CAD to direct a tool, it will be tied to that CAD. So if I delete the CAD, I end up messing up the tool plane or tool. So I'm going to go ahead and grab these guys and move them to level 4, and then go back to level 1 as my active. So let's go mill tool path. We'll go contour. And go to wireframe. I want this line. Oh, you know what? We're going to have to rebuild this. This is a flattened circle. So let's see. Let's go ahead and rebuild. Let's go ahead and send these back to level 1. And then with a CAD tool, I'm just going to draw. Oh, with level. Before we do that, we got to make level 4 active. CAD tool, we're just going to draw a simple line from here to here, and again from here to here. Now I can turn the visibility of level 1 off, and now we have just some simple lines. The lines that we had were squashed circles. So mill tool path, contour, we want that chain, that's the right direction, and this chain, and that's the right direction. Tool, 3/4 inch. Cut parameters, we're going to leave it 2D, everything's at 0. Depth of cuts, we're going to do it in one hit. At least, we'll probably do it in 2 passes. Don't need to lead in, lead out. We'll turn off entry and exit, and this will just contour. Now, in my last video, I had a hard time with this stuff. It's because I was backwards. I thought the second column was percentage and the first column was length. They're backwards. First column is percentage, second column is length. So we just need to extend past our lines 50% of the cutter and make sure they are being extended. We will want to do a multipass. I'll have one rough and one finish. Linking parameters. Top of stock this time is going to be about right there. We're going to copy that over to here, add 100 thousandths to it. We're going to retract absolute. This is absolute, and depth is also absolute. We're going to just add a little bit more to it so that we know that it's clearing. So that looks all about right. Planes, top up. Going to prove it. And see, as it comes through, it's making all these nice cuts. Comes up, clears over, and does the other side. So as usual, let's go ahead and see what we got. Looking pretty good. Now it looks like we have an issue here. That's not really an issue. That's just this cut, remember, is reaching down. So let's go ahead and move on to the center bore. Now instead of, let's go through here. We're going to copy this guy here. Remember, that's the tool path we used on the bottom. So we're just going to use the same one on the top and just change some parameters. So parameters, first we need to do is our WCSs. So from bottom up, we want top up. So it's looking at a different location from up here. Still use the same roughing, entry motion. We don't want any finishing. We do want depths of cut. We also want 10 thousandths left on the wall, so everything looks pretty good. Our linking parameters should also be enough to meet us halfway through. So we'll regenerate that tool. Let's make sure it's running the right way. Let's go ahead and just simulate that one because I want to make sure I got it running the right way. It's not coming from the bottom. It shouldn't be. Well, looks like it is. Shoot. Oh. Let's go into parameters again. Planes, top up, and we need to push that over. That's what happened. And also, while we're at it, redo our chain to the top. Yeah, that should look better. Let's go ahead and look at it. Make sure it's coming in from the right direction. Yes, it is. So there it is. We need to simulate everything to make sure we are going all the way through the part now. I missed some operations. Okay, so I want to make sure we look down in here and we're seeing this little checkered step pattern. That means we're overlapping on our cuts, which is good. Okay, so we need to now bore out the center of that hole. The diameter of that hole, we're going to have to create this one, is 1.00 to 1.02. Let's go ahead and make a boring head at 1 inch. Mill tool path, this is using a drill when we're boring. Select the center of the hole. Prove that, and we are going to be doing drill. We're going to be doing drill. I know it doesn't make sense right now, but well, trust me, that's what we're doing. So let's create a new tool. We're going to be doing a boring bar. Cutting diameter is 1 inch. Overall length we want 6. So we want to make sure we're clearing it. Cutting length is fine. Tapered angle is fine. Corners none. Shank diameter we're gonna 0.75. Shoulder length. Yeah, it looks kind of weird, but that's okay. Six feed rate. Probably want a 2,000 per revolution feed rate. So sticking with thousandths, 1,000 RPMs. 2 inches per minute is our plunge rate. Worried about our feed. Retract rate is also going to be at 2 inches a minute because we want to. It's going to be a bore in, bore out, and we want no coolant on this. Oh, we want to set this right here to boring number 1. So what happens now when I come to cut parameters, this bore number 1 is automatically set. We don't need a dwell because we're not going to be bottom boring. Linking parameters, top of stock. Top of stock is actually at 0. The depth, we're going all the way down to here. I'm going to increase the depth by just a little bit so we get through it. Make sure this top up, and that should be it. Now that's a drilling operation getting all the way through. And as usual, now this is our last operation on the top. We're going to go ahead and see where we're at in the simulation. Bottom. Going through from the bottom. Small drill. And there we go. Nice boring operation all the way through. So all we have left to do now is some side operations. Now for the side operations we got to go drill and bore this guy out, and then also run a small tool up there. And you know what? It's going to be impossible. We're going to try to machine this as best we can. We may come in, I think we'll come in from the end. We'll have to add another operation. So that's fine. So this fillet is actually going to disappear. Remember how I said, well, you know what? We can actually achieve that ball mill. We're going to come in and we'll machine up to here, and then we'll come in with a ball mill and machine that fillet in. So let's take and we'll place this guy on its side now. Groups. Toolpath group. Side up. We're going to do a new origin. I'm going to put in the center of this bore. So let's go to WCS, Plane Manager, Solid Face. Selecting that. Going to toggle through until I get the one I like. I like this one. Just to make sure, I'm going to reset the origin to the center of that bore. It didn't move, so we're good. Give it a new offset. Yeah, we'll go ahead and leave it at 0. We're going to assume this is a different orientation. I'm not worried. I'm not really worried about offsets in this. Now let's go ahead and set it to 2. What the heck? Side op. Side ops. So we'll prove that. So top op, so bottom has 0, side op has 1, top op has 1 and 2. So we can assume this is our different stations within a fixture. Prove that. So WCS, name planes, side op, planes, name planes, side op. I should say right here now. So first things first, we'll take and we'll do a pec drill. So I'm going to highlight this guy here. We're going to copy him, paste him down here, open up parameters, change our planes to side ops and push it through here. Leave this at -0.05 still, and we're going to have to reselect our geometry. Center that. Let's go ahead and regenerate and see if it did it right or not. Doesn't look like it. Parameters. Plane side up, we're good there. Linking parameters, top of stock. It's here. Depth, 50 thousandths. Prove that. And let's simulate it, see if it simulates correctly. Or not. It looks like it's doing. Oof. What kind of cutter is that? Impressive. Ah, we have this drill selected. That's what it is. Should be the number 3 drill. Take a look at those feeds and speeds. 1500. Feed rate of 5. That should be better. Okay. Simulate the whole thing. This doesn't look too bad, except it looked like it drilled way too deep. Oh, that's because we have everything machined off. We're good. We'll set to absolute. Try that. I just want to simulate just that one. Oh, you know, it's going to look like it's drilling real deep because I haven't machined that off. So it's going to look good. Okay, so now we need to bring up that 3/4 inch drill that we had used before. Wait, let's see what size of hole that is first. It is 0.688. Let's pull up that Z drill, and we'll go with the Z drill. So we're looking at the pack drill here. We had 3/4 here. Center drill. Chip brake, there it is. So we'll use this guy, we'll copy it. No, let's not copy it, let's just create anything new. No big deal. This one's pretty easy. Mill toolpath, drill. Just center of that. Tool is our letter Z. Everything's already set. Cut parameters, peck drill. We'll do chip brake. 0.413 divided by 2. Now let's go full depth per brake. Linking parameters, top of stock is actually at 0, and depth is down to here. And we're going to need to make sure we have tip comp. I want to bust through 100 thousandths and add a tip. No, let's go 50 thousandths. Let's go 10 thousandths breakthrough. Plane side ups, tops, coolant on. There, so now we got that going through. .688 is 11/16 drill. We're only going to drill this guy. We're not going to say this guy needs to be bored. So yeah, well, let's just come back to the parameters of this chip right here. Instead of this letter Z, let's find 11/16. Here, I'm going to show you something else too. Let's go to select library tool, turn the filter on, equal to 11/16 drill. Move that, and that's how you find it real quick. Now we do have to do our feeds and speeds for that. So 4 times 80 divided by 11/16 is 465, divided by 2 is 232. Times say 0.005, feed rate of 1.16. It's about 2.5 thou chip load. That looks good. Cut parameters. We'll go full depth. Linking parameters are all still good. Tip comp is good. We'll prove that. Regenerate, and that looks a lot better. So what else we got left to do? We have we'll call this side operation 2. How about that? And we're going to set the origin right here at this corner of this piece right here. So let's go machine group, and we're going to create a new group. Actually, we'll call this pad op, because it's kind of a pad. We call it, if side op 2 works best for you, that's fine. So plane manager, solid face, this guy here. That looks more appropriate for me. So go ahead and do that. We're going to change our origin up to here. Get a unique work offset. Call this pad op. Prove that. So we'll go WCS, name planes, pad op, planes, WCS, name planes, pad op. Okay. So now what we're going to do is we're going to come in and we're going to mill this thing flat with a just a standard flat end mill, a small one. So let's go mill tool path, and we're going to do a pocket. Make sure we do a chain select here. You know what? That's not going to work, because what I wanted to hit this edge here, and I want it to go beyond all these edges. I can't do that with that in one operation. So let's go ahead and do a create curve on one edge. We're going to duplicate these edges here, those three, and then I'm going to do X form offset contour. Okay, it didn't like that. So we got to do X form offset. So offset it maybe 1/4 of an inch. That looks okay. Well, let's take a look at the end. I'm gonna make sure I don't hit this. So 1/4 inch is too far. 0.1 looks better. We'll need to connect them and rejoin them, and then we'll go from there. So we need to come to the trim icon. We'll do an extend. This one and this one. These guys. I'm going to connect the ends together. So we're going to use this whole chain to drive the tool. So now with select only, I'm going to do wireframe. I'm going to just select those 4 guys and move them to layer 4. And these 3 here, I want to make sure they're on level 1. Yeah, they weren't. Okay, So now let's do let's do machine mill tool path, pocket, and do wireframe. We'll select this chain going around. Now tool, we got to be careful what type of tool we want to use. We want it to come all the way across and hit this chain, so we need something 200 thousandths end mill would be okay, but that's kind of, we don't, 200 thousandths is kind of oddball tool. So let's go ahead and we'll create a new one of 128 eighth inch or 3/16 end mill. So cutting diameter is 0.1875. Overall length is 3. Cutting length, we'll do a 1/2 inch on this guy. Corner type is 0. Shoulder length is 0.75. Shank diameter is 0.375. Now we better make sure we get one that we can get actually is a 1/4 inch diameter. Taper angle 45. That looks okay. Let's go next. Feed rate 4, and this is carbide, times 80 divided by 0.1875, and we're going to multiply that by 3, so we can do 5120 on our spindle. Now let's do chip load times 4 flute times 0.0015 chip load. Keep this one small. 30.72. Plunge rate of 20. Let's do a plunge rate of 10 because we actually will be doing plunging with this. Clockwise number 4. It's carbide. We don't want any coolant on it. We'll call this a 0.1875 end mill. Rough step 45, rough step in Z 50, 30, and 10. Actually, we can leave this at 52. Finish. Cut parameters, we are going to be leaving no stock on the wall. Roughing, we are going to go true spiral. Next, let's go one way. Or zigzag. We'll do zigzag. Entry motion, I want a helix entry. We don't need a finishing paths. We do need depths of cuts. So let's go 0.1875 divided by 2. About 90 thousandths depth of cut. Finish cuts, we'll leave that at 0. We'll do keep tool down. Linking parameters, top of stock is here, plus 0.125. Feed plane, that's okay, and retract above this part. And leave it in absolute, and depth is there. Make sure we got pad op, top, we're good. Okay, so now this should come through. We're going to review this, and we're going to make sure that it actually comes and does leaves a nice crisp shoulder here. And on top of that, it doesn't collide with anything too. Okay, so leads a nice crisp shoulder here, and we're going to come in with a ball mill and finish that up, because the engineering team says that we need that fillet. Okay, the fillet size on this is 120 thousandths. Actually, it's 90 thousandths, I believe. Let's pull it up. Yeah, it's 90 thousandths, so we have to create a custom tool for that. So let's do mill tool path. We will do, let's do a, trying to see what would be the best. Let's do a surface rough flow line. We'll leave it undefined. Oh, I forgot this nice little thing here, so I got to restart here. Mill toolpath, surface rough, flow line. Now it's asking for me to select drive surfaces. None of these are surfaces. So I have to activate solid selector and make sure I just have this icon here as my surface face. And that's my surface face I want. Now I'll have to hit enter twice. Let's see. Yeah, I'm cool with that. I like that. So we want cut direction to go this, so I'm going to go that way. Make sure let's go this way. Approve that. We are going to create a new tool. We're going to do ball mill. Cutting diameter is 0.18. Actually, let's do 0.175 or 0.125 actually. We're going to have it created all for us. So overall length needs to be 3 inches. Cutting length 0.5 is fine. It's full radius. And shank diameter is also 1/8. Feed rate 80 times 4 divided by 0.125 times 3, 7680 is the spindle speed, times 4 times 0.001, 30.72. Plunge rate 25, let's do plunge rate 20. Let's do plunge rate of 15, half of this, because we are technically doing some plunge rating. Clockwise carbide 4 flute, we're going to say it doesn't like coolant. I'm going to leave these all 0. Surface parameters, stock to leave on drive. And we'll take it all the way down to 0. We'll do this all in one pass. And we'll leave a scallop height of 1/1000. Actually, let's do it with half thou. Maximum step down is 0.005. It has this little bitty toolpath for us. Let's go ahead and run that. I want to see if what it's not doing. It's not realizing that we have material to cut out, and it's trying to cut a lot in one shot. Okay, let's go ahead. I don't want to do this. Let's go ahead and show you what's happening first. Just taking these two and simulating it. We'll slow down the speed here. So this end mill's coming in doing this pocket all just fine, no problem. The ball mill now comes in and it's going to try to take that all in one shot. Bam! That would absolutely break the tool. Not to mention we're really getting in, and I think we're getting really close to our fill. You know what? For the purpose of this video, we may not even worry about that. Yeah, engineering wants that, but it's really hard to get in there without a proper fixture or something. We may have to, actually, you know what, let's go ahead and keep doing this. Shoot. Okay, well, this is supposed to be a much more difficult project anyways, and engineering is saying, yes, we absolutely need that fillet. This is a high stress part, and if we go with a 90-degree cut there, we create a shear point, basically. So what we're going to need to do is we're actually going to have to create yet another offset, a fixture point, where we hold this part at a 45 degrees to the spindle so we can get our ball nose down in there and make that cut. So in order to do that, we're going to get rid of this guy. We don't need this. Make sure you only have one checked, and we'll delete it. Now we need to come to the front face, so I'm going to go WCS, front, and planes, front. Let's go planes top. So top WCS on the planes. Let me draw some here real quick. I want to see where that Okay, yeah, that's exactly what I want. So what we got to do, looking at this part, is we need to create a line kind of coming off of this at 45 degrees for our orientation of our origin. So I'm going to make sure I'm in 2D snap. I'm going to snap to this corner, and I'll put an angle of 135. That means I'm drawing out at this angle here. Now I need to create another angle at 90 degrees. Oops. I didn't approve that before doing that. So we'll snap to here. 135. Out to here, enter. Create another one off of here, but this time we'll go 90 degrees. Well, 135 plus 90. So I went at 90 to that one. So 135 plus 90. There we go. Out here. And now I need one that basically comes off of here and out into space. So we're going to switch to WCS and top. What I'm basically doing is drawing my X and Y axis. This at 90 degrees. Then go to WCS top. Okay, so now when I look at the top, I'm looking at the top. So we need a line coming off of this point here. Go back to three-dimensional snapping all the way to the bottom. I want to snap here. And I want to come out 90 degrees. And there we go. So why did I draw these lines? Well, this line here is going to represent the z-axis, negative z-axis, pointing at this fillet. We're essentially going to be having a part stuck in the machine kind of like this, so we can come in and get access to that fillet. And like I said, engineering says we must have that fillet. So it's called WCS up again, plane manager. We're going to do from geometry this time. I'm going to select this line and this line that we just created. I'm going to toggle through until Z's up, X is to my right, and Y is in the back. So I like that one there. We're going to call this angle up and give it unique work offset. Approve that. So we'll go WCS, name planes, angle up, WCS, or planes, name planes, angle up. See, now we got this oriented according to these CAD lines. Now I have these CAD lines in my tool plane. I need to move those back to level 1. So right click on level to level 1. Okay, so is this the best place for origin? Probably not, but it is going to be effective in allowing us to kind of get in here and do this machining operation. So we're going to create a new group. I'll call it angle up. We're going to do surface high-speed rest roughing. Start with that. Now, what my plan is that it's going to take in consideration all the machining we've already done. So it's asking for select drive surfaces. These are not surfaces, they're solids. So turn on the solid select with the surface filter, and that is the surface we're looking for. Containment boundary. We actually do want one. We are going to do a chain select, and it's going to be that face because you don't want it to go outside of that. And like I said, hopefully I get this right in the first step, but we'll see. So we already created the tool, so we'll reuse it. The cut parameters, use climb, toolpath type, rest roughing. What the rest means is it's actually looking at the area around it to see what materials left, come in and machine it out. So cut parameters, step downs they're okay. Diameter step over, we're going to change this to 30. Stock to leave, we're going to leave 10 thousandths on everything. Rest material, it's going to look at all previous operations as to what material is left, and it's using our stock that we use, the casting, as our basis, and then all the cutting tools what's left. Linking parameters, we'll leave all this information the same, just make sure we got our angle ops are appropriate. We'll approve that. Now let's take a look at that toolpath. Let's see if it actually did anything. Should have. There's a long operation here at the back. So I'm going to stop it right there. Bring the speed all the way down. What the heck was that? Oh, it's just a transitional move. It wasn't actually cutting. Bit. So no, it's not actually doing anything. This is just the pocket. Okay, so it didn't cut this out. See? So okay. Let's go back to parameters here. I don't know. Let's go to geometry. I'm going to take out the containment boundary. Doesn't like that. Let's go up the air. Let's go to area clearance. Still use the same tool. Cut parameters are all fine. Let's go to opti area. I think it has a climb, step over 30%, step down 10%, micro lift distance, not really concerned about that, 100, 10 thousandths to leave. Now let's go all the way to 0. Tool containment, transitions, helix only. Regenerate. It is still not doing it. I absolutely don't get it. Okay. Let's delete that. Let's do a flow line. Okay. Retract. Incremental feed plane is okay. Rough flow line. Scallop height of 1/1000th of an inch. Do a cut from one side. We'll allow multiple plunges. Let's do cut from both sides. Improve that. Okay. Now that's looking better. Problem is we're doing it in one depth. That's the bad thing. We may have to leave it at there for the sake of brevity. That's pretty close. I'll be happy enough with that. At least got us mostly where we wanted. It's still not looking great. The reason why this is still sticking out is the casting. We could go back and tweak it a little bit more, but like I said, for the sake of brevity, we're going to go ahead and leave that fillet. This is not ideal, but I kind of give you an idea of how to use some angled operations. So that is it for now on this program. Let's take a look around, make sure we got everything else. We got drilled through. Yes, this was definitely one of the harder ones here. I'd like to see if some of you can spend some more time and figure that one out. Okay, you have any questions? Let me know.